what you've been waiting for. What is new in 2.0? A few things. What we aim to do here is solve storage performance problems. Simple as that. We want you to understand how your workloads are interacting with your storage system. We want you to understand how Infinio is benefiting your data stores, your storage, and your applications. We also want to bring this to the block market so that all unified storage systems, independent of protocol, can take advantage of Infinio. And the last thing is we want to tell you how to resize your cache. And I think you're going to like this, and we'll jump in 2 seconds. So, SAN, block support, unified storage. Obviously, the protocols. The experience is exactly the same as what I'm about to show you. We're going to be demonstrating an NFS data store, but the block experience, there is no difference.
I don't understand. Experience is exactly.
Oh, no problem. So the last thing is that even in the world of block, it's perfectly transparent to your operations, to your storage system. Application level reporting, that's another feature. This is what lets you drill down into the VM level. We've got Cache Advisor. I don't want to spoil it, so I'm just going to say that this is resizing plus VDI enhancements. So in particular, there are algorithmic optimizations that for the same amount of memory yields an improvement on cache hit rate up to 10%. So that's a pretty significant change when you can say that I can use the same 8 gigs of memory per host and jack up my offload by 10%. So let's get into it. Just give me 1 second to sort of reposition here.
So when you say you're tuning cache, do you have different profiles depending on what the workload's going to be?
Yeah, it's dynamic. We want to keep as few buttons, as few knobs as possible. So there's basically a filter that sits in front of the cache to make decisions about when to promote into the global cache. That's how we're optimizing this algorithm.
So you say installation of the version 2.0 is just as transparent as the version 1. How do you handle the installation for the PSP?
It's a VIB, and we can do that through the vSphere API, the deployment.
Yeah.
There's also the OVA that we deploy, which is the actual cache. And all of that communication ties back to this management console. Okay. So I'll actually demonstrate that.
I got a brain cramp. PSP?
Yeah. The
path selection policy.
Thank you. Okay.
Yeah. So I really do wish that there was a little bit more contrast here, but believe me, it is not just a page of white. So you know about our architecture, the deduplication. We're deduplicating at a 4K block size. We're taking advantage of all that memory, distributing the content evenly. And what that yields, in this case, we've got a 3-node cluster, 8 gigs each. That's 24 gigs of physical memory. Right now, that 24 gigs is turned into 37. It was turned into 88. Typically, what we see in VDI is up to a 12x deduplication. All of our demonstration systems in the booth right now, they're seeing between 7x and 8x. So as you can tell, it changes based on the dynamics of your workload. So in this case, with our 24 gigs of physical memory, what we're offloading right now is 75% of this workload, which represents 3,000 IOPS right now off of this setup. And actually right up here, this is the past hour. Right now, it's actually at 5,700 IOPS with 8 gigs of memory from 3 hosts. So if 75% and 3,000 IOPS is not interesting to you, we have a feature for you. Manage caches and adjust cache size. So what I can tell you is that today, you cannot find anyone that will tell you how much cache you need for the workload you have. Instead, the typical answer is put an SSD into every single one of your servers. 200 gigs will do each, and that should cover it. But what I'm about to show you is that the way we handle this is we actually run your I/O patterns through 3 parallel caching strategies. Your current memory size plus 9 gigs, plus 18, and plus 27 gigs. Now, based on the amount of memory that you have available in your cluster, we'll dynamically adjust those pools that we do these measurements against. And what we can tell you definitively, this is not a model, an estimate, or anything like that. This is an actual measurement. We can tell you that if you give us 9 gigs of memory, we will give you 99.2% offload. You give us 18, you get 99.6. Give us 27, and you get 99.8. And what this should tell you is that there is absolutely no reason why you should give us anything more than 9 gigs.
Right.
You've reached an inflection point where you're at the point of diminishing returns, right? Meanwhile, you could also go buy hundreds of gigs of SSDs, but 9 gigs will do. So, at the end of the day, you decide, I'm going to go with 33 gigs. You click that, this jumps up to 33 gigs. If we scroll down, you see this is your per host memory usage after you commit the change. But right as you're doing this, you remember that later in the week, you're actually going to onboard a new workload, something that you expect will really clobber the storage system. So you want to get ahead of it. What you do is you take this little slider here and you dial in the amount of cache you want. You just dial it in. And at some point, so we're at 800 gigabytes of cache. At some point, this thing turns red. And what that's telling you is that this ESX host, if you commit this change, and you do not have DRS automation fully automated, this host will, maybe the balloon driver will kick off, or it'll swap, which you clearly don't want to do. So the simple answer to fix that is you take the slider, you pull it back, you click the lock button, that locks in the memory on that host, and then you readjust the other two. Done. So you're happy with 725 gigabytes of DRAM-based, distributed, fully deduplicated caching. So let's commit the change. You come up here. This is where you are, 8 gigabytes. You're going to go up to 242 gigabytes, and so on. When you click this, it is a fully automated change. That's all you had to do is click resize.
Is there any opportunity to do this programmatically? Let's just say we have an event that we know that we have particularly high workloads.
That is a great idea.
Push it in and then
It's a great idea.
shut it down after hours.
It is now on the backlog.
Yeah.
So how does it apply these new reservations for the VM, for the caching VM?
It does it through the vSphere API. Okay. Our management console makes calls out to vCenter.
Yeah.
It basically resizes the cache, applies a new reservation. This is your reservation, this is memory usage, and you're off to the races.
And it basically shuts down the cache VM on each host.
Precisely. It does it in a circle.
Yeah.
So you take your cluster, and it goes one by one.
Yeah.
Brings it up, goes on to the next one, and it does it all in the background.
And there's no need to reheat the cache.
So the cache, after it comes back up, the cache is going to warm up again. And I'm going to show you in just a second exactly what that looks like. So after you've resized to 725 gigabytes, I guarantee you your next question is, what did I get out of that, right? Of course. So all we need to do is go up to home and jump right into the data store. What we're showing you up here is a time range selector. This represents 2 weeks of data at 1 minute granularity for the duration. There's a little window that you can slide to zoom in on specific areas. You'll note these little dots. What the dots represent is points in time where the backend storage system had a very high latency spike. But because of Infinio being there, your workloads did not suffer from high latency. So we basically eliminated, masked a storage latency spike. So let's just look at one. So we've got at 10:30, backend storage was at 80.1 milliseconds, and that's actual measurements. We see I/O passing back and forth, and we're measuring it. Your workloads, however, instead of getting 80.1 milliseconds, they got 5. They saw 5 milliseconds of storage latency because of Infinio. The reason we can do that is because of this. That gray line right there, that represents your total workload. The blue line represents our offload. One thing you might note is that there's this line. Everything in this UI is vertically aligned. And a line runs straight through all of the charts so that you can simply scroll down and see correlation across all of your charts. And what we've actually done here is, if we go down here, we're actually seeing per VM metrics. This is actually all of the offload on a per VM basis. So we do it for every VM, every data store. You can actually even go and see response time on a per VM basis.
Can you fix that line, or is it just
yes, you can click and it drops the line there and it makes it basically stuck.
Yeah, because if you want to scroll downwards, then
precisely
the line you're exactly looking at.
You got it.
Yeah.
So
how much data and analytics are stored, and where is this stored at?
2 weeks at 1 minute granularity, and it's stored in the management console.
About how much? What's the size of that 2 weeks worth of data?
It's not actually big. So under the covers, it's RRD, which is a very efficient storage mechanism. So in fact, we only take 20 gigs of storage on the storage system for the management console, and most of it is just unused. So why don't we actually dive down into one of these blips and see what we can figure out. All right, so we'll take this one that we were looking at before. We're just gonna zoom in. All right, so we can see it right there. I think the goal should be, we should try to figure out what caused this. So we know that our VMs enjoyed 5.4 milliseconds of latency, but any administrator worth their salt, they want to actually know what caused it. It's great that we can identify your storage system had a problem, an anomaly. Infinio fixed it. But you still want to know what caused it. So we're going to do our vertical alignment, and we're going to scroll down. I don't see anything here that would indicate what that problem is. So we're going to actually jump into a totally different view. You go right here to Analyze Workload Composition. And what this shows you is these are the top VMs that are generating I/O. These are the top VMs that are being offloaded. And these are the VMs that are being least offloaded. Now you can also look at it from the perspective of response time. This is your fastest VMs from a perspective of latency. These are your slowest. But getting back to the task at hand, we want to figure out this. So we're just going to drop our line here and scroll down. And the first thing we'll note is 3.8, 6.4, 6.2, 266 milliseconds on that VM. So I venture to guess that we should look at linbuild 2, because it probably has something to do with this problem. And I guess the real point here is that our ability to identify a storage problem, identify that it's solved, and then identify the VM that could be the culprit, like that, is really powerful. You don't have to go wading through charts in vCenter or whatever tool you happen to be using. So that is our VM level statistics. You can also naturally do searching on a per VM basis. So in the case of VDI, for instance, if some user, Paul, calls up and he says, listen, my VDI was slow, yesterday, you can actually recall Paul's VM and look at the offload rates and his individual VM's latency, just like that, compare it to other VMs to understand if it's in line or out of line.
Is there an opportunity to actually bring this outside and maintain a longer set of historical data? Say if we were doing real...
Yeah, potentially. We don't have an interface yet for that, but...
Support today?
Nope. You would have to crack open the RRD files.
Challenge accepted.
Yes. Yeah, no, it's totally doable. Totally doable. So the last thing I'd like to show you is what it's like to actually own this thing. What's the day one experience? So on day one, you don't have any Infinio. We're going to send you a double-click installer. It's literally an executable that you can run on any Windows box, your vCenter server, even your laptop. You point that at vCenter, and it automatically deploys this VM, the management console. Now, when you come in here, you're just going to see a list of data stores with these blue accelerate buttons, right? the extent to which you administer Infinio is doing this. You click accelerate, you confirm your selection, and what it's doing right now is it pulled your inventory to determine which ESX hosts have NFS VDI1 mounted. It automatically deployed the software, stitched it into the active I/O path, formed a distributed cluster, and it did that without maintenance mode, without a restart, without even an interruption to your I/O. One button, that's it.
Where does it fail? It always looks nice in the demo, and what have you seen out in the field where there's been situations where the deployment has had challenges?
It rolls back, that's what it does. So what you would actually see, I won't induce one, but not the time or the place. But in that list, what you would see is a red X, and then you would see it start backing out the changes. Also, if there's ever a reason to remove Infinio, and there are legitimate reasons, right? So let's do it. You go into Manage Caches, you click Remove All Accelerators. Once you confirm this, we systematically deconstruct our cache, taking it out of the I/O path, leaving nothing behind. Your ESX servers talk to your storage system. End of story.
And triggers the call center.
So the reason
Find out what happened.
the reason you would want to do that, though, is let's say, for instance, you've got a flapping LUN. A data store is going offline, coming back online erratically. The first thing you're going to want to do is eliminate variables, right? So you say, Infinio, out. You click that button, 5 minutes later, Infinio is gone. If the problem persists, wasn't us. So getting back in the path, all you have to do is click the accelerate button, and you're back up and running.
So no issues with the dedupe and the pointers that you've got if you've removed it?
Oh, yeah, so if you remove it, all of the content, poof, it's gone. So then it has to ramp back up. And you know what? That reminds me, I meant to show you what the ramp period is. So how long does it take to go from 0 to meaningful offload? That's the question, right? And we've got an example right here. You can see, and I apologize, I'm on a RDP session over VPN, and it's a little laggy. The workload started right here, and you can see within, let's just mouse over it, started at 10:35. By 10:50, we were already offloading 4,300 IOPS. So it's a very quick ramp. And you know, that is the product. That's 2.0. So if you have any questions, fire away.
Would it ever make sense to stick this product in front of a flash array?
Yeah, I think the idea of server-side caching, being that you offload all downstream components, is that if there's variability in the performance of the flash array, because it is still a shared system, right? If you've got your flash array carved out to 5 different data stores, 4 of them start ramping up, well, potentially another data store, the one that isn't ramping up, could have a penalty. So how do you solve that? Well, I would say putting server-side caching and offloading from all downstream components is the right idea, which is why we can do this, right? That's exactly what this shows right here. The blue line, flat and fast, that is Infinio's latency. This is sort of the erratic nature of the backend store. And while Flash, from a backend perspective, is going to be a lot faster and a lot smoother, everything has limitations. CPU, if there's CPU contention, that's going to cause erratic behavior. So I don't see a reason why you wouldn't want to, at the very least, try it. And of course, at $4.99 a socket, I think from what most of the customers we've talked to, they say that is a no-brainer.
$4.99 for the year.
Yep, exactly. It's a subscription.
Almost too good to be true. That's the amazing thing.
You also mentioned something about continued innovation for the VDI side. Any more on that?
Yeah, so the algorithmic changes, as well as being able to identify a user's VM to really see what their user experience from a storage perspective was.
There's a couple of things in particular around VDI, if I can interject.
Oh, of course.
That are benefits here as well, both with the 1.0 and the 2.0 that we're doing. Number one, I had a lot of experience with VDI customers, and typically people will dedicate both the servers to their VDI deployment. They don't tend to run mixed server workloads as well as VDI workloads because of the I/O. Also, though, a lot of times, though, on the back end, they want to use the same storage device. So you wind up having very spiky behavior on the back end array, which in turn results in poor user experience under load for the VDI sessions, because VDI in particular is not like a server workload. It's really driven by, interactivity of what you have the focus window on. So Infinio both mitigates two different aspects of that. Number one, it can mitigate the shared nature of mixing the server with the VDI workload. Also, it can radically improve the user experience on the windows that have focus. So the heuristics that we're going to add are going to give more hits to the cache for things that impact directly the user's latency and user experience. Does that make sense?
It's the hard part that we always see is that we're always being told about the abstraction layers that are happening below, and we just sat with some other vendors who talked about their, flash product, and flash aside, hybrid arrays. They try to move all their acceleration inside and get their efficiencies in there. Do you find that there's going to be sort of pushback on, like, we don't necessarily need the acceleration here because it's already happening under the covers? Now, I know we've seen it in traditional spinning disk. It's not going to be a tough sell, but we're going to get acceleration. You could probably put a 8 gig, SanDisk thing in there, and you could probably get acceleration. But
I think the key is that when you're sizing an environment like that, you have to size everything between the workload and the persistent media. So that can include HBAs, networks, controllers themselves. And that's, I think, why server-side caching is a permanent fixture in the data center. Because the idea that you can offload from these downstream components means that your right-sizing exercise for, these modern storage architectures is well, you don't have to be quite as precise and perhaps not overbuy upfront.
vSAN and vVols, any work that can happen inside that environment? I know that's, again, they're already sort of, at least vSAN side is, the IO filters stuff is going to target it, but so right now, just traditional SAN, NAS, and
exactly.
SC. Yeah.
Anything else?
It just works.
Yeah, no, it's really that simple.
The demo as well.
What do you find is the sweet spot as an entry point? Where folks that have smaller workloads, and obviously it would be good to have some acceleration, but a lot of SMBs and smaller shops, they may have, lower memory consumption already today in their host. So we're heavily oversubscribed on memory.
Great point.
And some people might find even 8 gigs is a surprising amount to give away to the product.
So we have never once, literally not once, had somebody say that 8 gigabytes is too much memory.
Really?
Typical memory usage is between 60 and 65% in all of the installations we've done. And we've got a pretty good cross-section. We've done, hundreds of installations, and we never see memory as an issue. Especially most recently, we have customers that are turning out boxes that have half a terabyte of memory each, and they've got 10 of them. So they have an abundance of free memory.
Is there something that you would think of, pulling analytics and then pulling them back into your environments in order to find out what the workload profiles are? And because that would be interesting to see. You talked about the DevOps, but saying like there's a DevOps shop and they get great acceleration. There's 1,000 different use cases inside that could tell us what it is, whether they're just spinning up new environments or what the scale and size of those environments are.
Yeah.
Have you got anything that you can show, like this was a specific reference case in a workload?
So aside from the resizing, what I didn't show you on resizing is so you can actually go back in time to identify a period for a specific workload that we would then tell you what caching effectiveness would be with a given size. But as far as giving more insight, like for instance, you might say give a histogram of request sizes, right? We don't have anything like that, but I would definitely like to speak with you off camera about some future roadmap stuff that you might find interesting.
And what about workload tagging or VM tagging so that we could identify and again, that might feed back into the overall environment?
Yeah, there's some interesting stuff.
Now, have you guys thought about, excluding certain VMs from hitting cache at all?
That comes up a lot. That is not something that we think is a good idea for a specific reason. Because it's about opportunistic offload.